Hello everyone, I am Sakshi Kesharwal and I'm maths expert in AskIITians. So today we'll be starting with the second lecture of whole number. That's last class we have done with knowing a numbers and we have completed the knowing numbers and we have done the basics of everything over there. So here we'll be learning about what is a whole number and we have learned till now that what is a natural number. So natural numbers are basically the counting numbers. We have already learned this in the first lecture. So what is a natural number? So natural number starts from one. Like if we say that is the first number which we have learned in our life, that's the first. What is the first number that we say that we learned in our life is the number one, right? So number one, then two, then three, then four, five, six, seven, eight, nine, 10. We have learned these many numbers and just keep on going. So these are the numbers. So counting numbers are said to be what beta are natural numbers, right? So we say that the natural number starts from what beta 1. Now, if I ask you, like, let us suppose if I ask you the question, like, I have 5 toffees with me, and I said that I have eaten all the toffees, right? So now I'll say represent how many toffees are left with you, right? So you said I have left no toffees, right? But how now I'll say how you're going to represent this mathematically, right? So this is the thing that you have to think. Right now, we know that the number starts only from one, right? We don't know any other number right now. We know that the number starts from 1, 2, 3, 4, 5, 6. Like this is the number we know, right? So over here, if I ask you, if you, I gave you 5 chocolates and you have eaten all the 5 chocolates, and you said that I have left with none, right? So how many chocolates? How that you said none chocolates? How you're going to represent this mathematically, right? So this is a one question, right? If I say like on a tree, like let us suppose on a branch of a tree, like 10 birds are sitting, like some birds are sitting and all of them flew away, right? Because of like something in it, just flew away. Then I said, how many birds are there on the tree now? Now you said like, there are no trees, like there are no birds on the branch of the trees, right? So this is the thing we say, like if I say the 10 birds, now I says there's some birds sitting on the branch of the tree. So first you will do what are the some birds. So what you will do, you just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let us suppose there are 10 birds, right? Then I said like 3 flew away, right? So how many birds are left? So you will do like, now you will be counting 1, 2, 3, 4, 5, 6, 7. 7 birds are left, right? Now, if I say all of them flew away, like all of 7 of them flew away, then how many are left? Then you will say, ma'am, none are left. So how you're going to represent this mathematically? We say that we say the word zero. See, zero has a very big history actually, if you're going to read it on a Google sometime, it is a very big history. It took world to accept zero is a very big thing, right? As we have learned in that is a Roman numeral, there is no zero. There's no number called zero. As we say, like this is like 1, 2, 3, 4, 5, 6 are the Hindu Arabics numbers, right? So Hindu Arabics numbers, so which came first? Like which numbers were the existence, which number was existing priorly? So Roman numeral came first, then the Hindu Arabic numbers which we are using right now, right? So if you go and read it out, the history of the zero, it's a very big thing. So it took world to like give the acceptance of zero was a very big thing, right? So that's all I want. I don't want to go in deep into it, but it's a very big story for the zero. And yes, then you have seen like Aryabhatta was the one who invented zero. Yes, he played a vital role in the acceptance of the zero in the world, right? So that's what we can say. And that's about the zero. So what happened if we include in a number system like 1, 2, 3, 4, 5, and if we have included zero into it, then we say that the whole new number system has been formed, and this new number system is said to be what beta? Whole number. I think so this is much is enough. Now let's go on a slide and what it is, right? So I've explained you what the things are into it. Yeah. So basically, the whole number consists of the weightage in your examinations from 3 to 5 marks, depending on school to school and depending on the Olympiads to Olympiads. So the questions in this like consist of like maximum of 5 marks. You cannot have the questions more than 5 marks from this chapter. It depends. Like if you have the IMO examinations, also you have such a weightage only, right? So let's go. What are the topics that we'll be learning today? We'll be learning We'll be learning the concept of zero, the special properties of zero, number line on a whole number, concept of predecessor and successor, arithmetic properties of whole number. This is important, and the properties of whole numbers and additive and the multiplicative identities of the multiplicative identity. So what we are learning right now, as I'll say, and you will be listening, you will be just saying, you will be when you will be like you will see the more of my recordings, you will see I'll be saying that beta these are very 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 basics, so please pay attention to each and everything and try to learn everything from it, right? Okay, so as I said that the what we said that the whole number, we have learned that what are the natural numbers, basically what are natural numbers beta. Now I'll just write it down. I think so I have given my explanation. What are the natural numbers? Natural numbers or counting numbers, right? Or counting numbers. We say counting numbers are what beta? We say like this. We say this, it is equals to 1, 2, 3, 4, 5, 6, dot, 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 right? It is denoted by, it is denoted by what beta? Capital N. Please try to memorize these small little things, these symbols, because this will help you, right? Now, if we say, now, what is our, like we have just learned what are the natural numbers, right? These are known as what beta? Counting numbers. Okay, now what is the smallest natural number, right? So smallest natural number is what beta? Smallest natural number is equals to what beta? 1, right? Now if I say you the ask you the largest natural number will be how much beta? The largest natural number is equals to what? It is like, now I'll ask you which is the largest. You will be thinking, ma'am, arab karab, like these millions, trillions. No, no. If the number what you have thought in your mind, let's take, you have thought a very big number, and if I come and just put add 1 to it, you'll get a new number or not? Yes. So you don't know that which is the largest number, so we say that the largest natural number is undefined, or we don't know, right? Some of you have been learned about the infinity. Infinity is nothing, it's like it's going, like there is no end, right? Infinity means there is no end, and the symbol only means there is no end, right? So we say this as undefined because we cannot have a specific answer, that is why we say undefined, right? So we say that undefined, right? Yes. Now this is we have learned already, right? Now let's coming to what is a whole number. So a whole number is a set. What is the symbol of the whole number? Like the we say what is a whole number? Yeah. What is a whole number? Whole number means what? Basically, what is a whole number? Whole number is what? Basically it says that it is like if you are going to add 0 in the natural number, then it becomes a what? A new set of a collection, that is known as what beta? Whole number, right? Now later on we'll be learning so many stuff over here, right? We'll be learning so many stuff regarding it, right? And you will see that that whole numbers means what? That the numbers which starts from the numbers which start from 0 1. Achha, 0 is a greater than 1 or 0 is lesser than 1? 0 is lesser than 1, so we are going to put the number on the left hand side of the 1. You're not going to put the 0 on the right hand side of the 1. So if you're going to add 0 in a natural number, so 0 1 2 3 4 5 6 dot dot dot, yeah, it is a symbol. Now it says that it's already written, it is denoted by capital W, right? So it is what denoted by? It is denoted by capital W, right? That's it. Now, I'll ask you one more question. Can I say like over here that all whole numbers, can I say that all natural numbers, can I say that all, can I say all natural numbers are whole number? Yes or no? So answer is yes. But vice versa, if I ask you, what is in vice versa? That all whole number, all whole numbers are natural number. So what will be your answer? All natural numbers. Then what will be your answer? Your answer will be what beta? No. Because the reason, because 0 is not natural number. 0 is not natural number, right? 0 is not natural number. So you can see this from the given figure that natural number is smaller than the whole number. So when we added 0 in it, it becomes a whole number. So this set, we say this set basically. So this we say that the natural number is a smaller than what? Whole number. So can I ask you what is the smallest whole number? The smallest whole number will be what, beta? Smallest whole number is what, beta? 0, right? Now, if I'll ask you what is the largest whole number? Largest whole number is what, beta? The largest whole number is again undefined. We say this as what, beta? Undefined. That's it. We say this as what generally as undefined. That's it. Okay. So this thing is very much clear to everyone. What is in whole number? What are the natural numbers? That all natural numbers are whole number and all whole numbers are not natural number. Yes, right. So let's do some arithmetic. I think so. We have learned even numbers. Okay, I'll ask you what is an even number. If you don't know, let's have a little bit of discussion. Okay, what are the even numbers, right? Even numbers which are like the multiples of 2, or we say that we say like z2 4 6 8 10, like 10 12 14 16 and keep on going, right? So can I say what is the smallest even number? The smallest even number is 2, and the largest even number is what, beta? It's still undefined. Now if I'll talk to you about what is an odd numbers, what are the odd numbers? Odd numbers are like this. Odd numbers are basically 1, 2, 1, 3, 5, 7, 9, 11, 13, then 15, and keep on going. This dot 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 means what? It keeps on going. There's no end. That's why we put a dot dot dot, right? So we put a dot just so that it doesn't mean like where it's going to end. You don't know where it's like what's the end point. So if I say like these are the even number and this is an odd number, and just see one a simple example over here, that if you're going to add even, if I'm, let us suppose I'll write even c plus even, let's take an example, right? So even plus even, let's take an example, 4 plus 8. Your answer is what? Again 14. So even plus even is what, beta? Even, right? I'll give you simple example, right? Now learn this even plus odd. Yeah, odd plus even, whatever you say in a vice versa form. So if take an example, 2 plus 5, it is equals to what, beta? 7. So even plus odd is what, beta? Odd, right? Let's take an example of this, right? Now, if I say that odd plus odd is equals to how much? Let's take an example, that is 3 plus 7 is equals to how much, beta? 10, which is an even. So even odd plus odd is equals to what, beta? Even. This is again an important thing, right? Now this is for the addition, right? This is for the addition, and let's go for the multiplication. Now if I say, beta, even into even, right? Even into even, like again 4 into 8 is equals to how much, beta? 32. This is again an even, like, yes or no? Yeah. Let's take another example, that is even into odd, right? So this is like 2 into 3, which is equals to what, beta? 6. So again even, right? Even into odd is what? Again even, right? Now if you see this, odd into odd, right? Odd into odd, right? If I'll say like 3 into 7, which is equals to what? 21. So your answer is what? Odd into odd is what? Is odd, right? This thing is much clear. So let's do the question over here. Which of the following statements are true and false, right? The sum of the two odd number is odd. Now you can just see these, you can do in your head also. The sum of the two odd, we just already did, that is sum of the two odd, and odd is what, beta? Is that odd number? No, it's false. It's even, right? Right? You can take some example in your head. If you forgot this thing, take an example like 3 plus 7 is equals to what? 10, which is even, right? The sum of two odd number is an even. The sum of two odd numbers is an even number. That's true. Just now we said. Okay. The sum of two even number is again an even number, right? It's true, right? Yes. Take an example. The sum of two even number is an odd number. It's false, right? This one is what, beta? False, right? We say that the sum of an even number and odd number is what? Even. So let's take an example of sum of even number is 2 and the odd number is what? 5. 2 plus 5 is what? 7, which is an odd number. So this is what? True, right? Now, coming to another examples, the sum of odd numbers and even number is an even number. The sum of odd, let's take an example of like 3 and then take it 5. So 3 plus 5 is what? Even number. So it's true, right? Now, every whole number is a natural number. We have already done it. No, it's false, because 0 is not natural number, right? Is not natural number, right? Okay, let's come into every natural number is a whole number, then again it's true. Okay, there is a whole number which when added to the whole number gives the number, right? There is a whole number which when added to whole numbers gives the number. Let's take an example like 5 and then take another whole number like 100, right? So if you're going to add this, it is 104. This is again a whole number or not, right? So this is yes, true. Okay, now there is a natural number which when added to a natural number gives the natural number, right? So there is a natural number and added to the natural number, right? So let's take an example of 1 and then like 1001. So this is a natural and this is a natural. So this is again what a natural number. It's talking about specifically the natural number. So let's go for natural number. So it's true, right? So this is 1002. This is a whole number as well as a natural number, right? So whatever you want to say, you can say either of it. But when there is a 0 and 1, then you have to be very specific about it, right? 2 plus 1 is 3 is not that number. 10, there is a natural number. When we add to the natural number, gives a oh my goodness, gives that number. Oh, okay. Okay. I read the question wrong. My bad. Gives that number. Okay, my bad. Okay, I explain you. I read the question wrong. Okay, I was in hurry. I read the question wrong. Okay, just read the question again. It says that there is a whole number which one added to the whole number gives that number only. Let us suppose if you're going to take 0, if you're going to take 4, and what should be added, like a whole number should be added, you should get the answer 4, right? So what should be added? It will be what, beta? 0. Yes, because if you're going to add 0 in any number, the result remains the same, right? But what happens if you add any natural number? If I say like 4 dash is equals to 4, is this possible with any number, any natural number? It's not possible. If I'm going to take 1, so this is not equal. So this one is true and this one is false. Sorry, my bad, beta. I just read the question wrong. Okay, I just read the question. It says that whole plus whole. Okay, so yes, this one is true and this one is false. Okay, coming to the successor and the predecessor of the number. What do you mean by the successor and the predecessor of a number? Successor means what? The number just after your number. Like if I say like after 2, what is the number comes? That is 3. And what is the number before 2 comes? That's a 1, right? Let us suppose if over here the number written is what, beta? 100. What is comes after 100? It's 101. So 101 is successor. And what comes before 100, which is equals to what, beta? 99. So like we say that 99. Now can I say that 100 is a successor of 99 and 98 is a predecessor of 99? Yes or no? So generally what happened, we say that if one more, we say that one more than a given number, the given whole number is called its successor, right? It calls it successor, right? It's called its successor, and one less than a given number, when that is one less than a given whole number, that is other than 0, is called its predecessor. It's called its predecessor, right? So if I'll ask you an example over here, if I'll ask you an example like I'll write successor and predecessor of the number like 9999, and I'll give you like 1001. So what is the successor? Successor will be what, beta? 99,999 will be what, beta? It will be how much? 90. It will be what, beta? 1 lakh, right? Yes or no? Yeah, and it will be predecessor will be what, 99998, right? And what is the successor? It will be what, 1002, and this will be what, beta? 1000. That is your predecessor, right? Just with one before and one later, right? So we say that. So I'll just be writing these remarks for you, right? Okay, so what are the remarks that you should have? Okay, that's the first remark. The successor of whole number whole number is equals to given whole number plus 1, right? You have to just add plus 1. Second, that is predecessor of whole number is equals to given whole number minus 1, right? Now that's all we did in that one. So if you're going to add 99,999, if you're going to add 1, you're going to get 1 lakh. If you're going to subtract 1, you're going to get 99,998. Similarly, in 1001, if you're going to add 1, you're going to get 1002. If you're going to subtract 1, this is equals to what, beta? 1000, right? Now coming to this, 0 is not the successor of any whole number. 0 is not the successor of any whole number, right? Fourth part, 0 has no predecessor in whole number system. Later on, we'll learn that 0 have a predecessor and 0 is a successor of a number when we'll be studying integers. But right now, we are talking about the whole number system. So yes, it does not have, right? Okay. Now coming to the fifth part, 1 has no predecessor in natural number system, right? 1 does not have any predecessor in a natural number system. Okay, now I'll ask you one question. Okay, write the successor and the predecessor of like 531010, right? So this is equals to what, beta? 5,31,010. So successor will be what? Just add 1. So it will be what? 531011, and successor will be what, beta? 531009. That is your answer, right? Okay. Okay, you have to just add the numbers. Okay, so now let's coming to the number line, right? How you're going to represent the numbers on the number line. So we know that the numbers start from here and you have to make an arrow, right? So basically we say that it is a ray, right? So it is like basically it's like the end point is what, 0, and with the equidistance you have to mark 1 2 3 4 5 6 7 8 9 10 12, right? So what happened over here? Okay, just see over here. If you have a number line, right? So basically what this is your number line, and what happened over here, you have to just make a number line like this, and it says that if you're going to add a number, right? So what happened, beta? If you're going to add a number, it says that 1 plus 5. So you will go from 0 to 1, right? And then you will go one step ahead, like 5 step ahead, right? So I'll change the color. I'll change the color and just see over here. So you'll be going 5 step ahead. 1, 2, write this 1, 2, 3, 4, and then 5, right? So you have reached to what, beta? 6. This is for the addition on a number line also, right? Now it says that 7 minus 3, right? So it says that 7 minus 3 is equals to what, beta? 4. So first you go on 4, right? You go on 7, right? From 7 you just move 3 steps. When there's a subtraction, move left. When there is an addition, you have to move right, right? Now it says that over here. Now, if you see this over here, so this is equals to what, beta? 1 plus 5 is equals to what, beta? 6. Now this is equals to what, beta? 7 minus 3 is equals to 4. Now what is this? Now this is equals to what, beta? It says that 3 plus 3, then plus 3, then plus 3. So can I write this as that is 4 into 3? Yes or no? Yes, can I say this? That is 3 plus 3 plus 3 plus 3. Yes or no? You're adding 3 plus 3 plus 3 plus 3. So can I write this as 4 into 3 or 3 into 4? You're multiplying this is 4. So basically, what is a multiplication? Multiplication is what, beta? Repeated addition or not? Yes or no? If I write like 5 plus 5 plus 5 plus 5, which means what, beta? This is equals to what? 3 into 5, it means what? You are multiplying 3 times the 5, yes or no? Or you can write 5 into 3, both are same or not, yes or no? So you can just do, I'll tell you, like we can do this example right now. If I write 5 plus 5 plus 5 plus 5, which is equals to what, beta? 3 into 5, right? Or I can write this as 5 plus 3, 5 into 3. So let's take a number line, right? So if you're going to draw this on a number line, wait a minute. Okay. Yeah. So this is what? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15, right? Now let's draw another one. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and this is 15, right? Now let's take a color. Okay. Let's take a different color. Okay, it says that 3 times 5 means what? Just now we saw that you are adding like 4 times you're adding 3, right or not? You're adding 4 times of 3. So this will be what? You're adding 3 times the 5. So you'll be go from 1 to 5, 0 to 5, right? Then you will go again to 5 steps ahead. So this will be this. And again, you will go to the what? 5 steps, right? So you have reached to what, beta? 15, right? Now, if you see this over here, if you see this over here, now I'll take yellow color. It says that 5 into 3 means what? 3 times you're jumping 5, like you're taking 3 steps but jumping 5 times, right? So this will be what? 1, right? This is your 2, right? This one is your 3, right? This one is your 4 and this one is your 5. You're jumping 5 steps. So is this is equals to still 15 or not? Later on, we'll be learning these things only what it is. So you see that either you write 5, 5, 5, either you write 3 into 5 or 5 into 3, we get the same answer, right? Now, let's coming to the properties of the whole number. What are the properties of the whole number? See, there are 4 types of properties. We learned closure property, commutative property, associative property, distributive property. These are the 4 properties which we will be learning, and please take care of these things. And we are learning for the whole numbers. Once you understand what is a closure property, try to understand in your own language, right? So what do you mean by the whole number? The closure property means, well, let me change color, it's very light. Okay, the whole numbers are closed under addition and multiplication. Now you might be thinking what it is, right? So what this means, what if you're going to take one whole number and if you take the other whole number, take 2 whole numbers in your hand and just add it, right? The answer is again a whole number or not. If you take one whole number and take the other whole number, if you're going to multiply, the answer is again a whole number or not, right? Now if you're going to take a whole number and if you're going to take a whole number and apply subtraction, is it the answer the whole number? Always, not once or twice but always. So if you just take an example over here, it's wrote 5, 3 plus 1 is what? This is what? A whole number. This is basically once means what? Whole number, right? Whole number and whole number. If you take whole number 1 and if you take whole number 2, right? Whole number 1 and whole number 2, and if you apply the mathematical operation, right? So mathematical operation is what? Plus, minus, into, and divide, right? The answer has to be what, beta? Whole number. Whole number. Then we say it is closed, that is the given number, that is it is closed under that mathematical operation, right? Mathematical operation, right? So mathematical operation is what, beta? That is plus, into, minus, this is really very important, right? So you just see if you're going to take any whole number, like take 7 plus 8, right? 7 plus 8 is what? 15. 7 is whole number, 8 is whole number, so 15 is again a whole number, right? You take 4 into 4, like 4 is a whole number, 4 is a whole number, multiply, your answer is a whole number, right? You take 9 into 2, that is 9 is a whole number, 2 is a whole number, and the answer is again a whole number. This is what means a closure property. Closure property means what? Take a whole number and apply the mathematical operation, the answer has to be the whole number. That is why we say that the whole numbers are closed under addition and multiplication, right? So you just see over here, just see that if now let's talk about the subtraction, right? Just see subtraction, right? You just see over here. Now let me change my color once. Yeah, see over here, it doesn't change. Okay, just see 6 minus 2. This is a whole number, this is a whole number, and the answer is again a whole number. Yes. But if I say 7 minus of 8, right now you don't know this is the answer or not, right? This is not a whole number. Later on, we'll be learning, or this is what equals to minus 1, which is an integer, right? This is a whole number, this is a whole number, answer is a whole number. This is again a whole number, and we don't know what is the answer, right? So again, we say that you have to see that always it has to be what, beta? Always, always, always. So we say that whole numbers, we say that whole numbers are closed under addition and multiplication always, right? Multiplication always. Okay, coming to this part, over here you see that this is not a whole number, no, yes, no, right? So we say that it has to be always, always, right? So this means what? We say that whole number, we say that whole number is not closed under subtraction. Yeah, whole number is not closed under subtraction, right? Now let's talk about the division, right? What do you mean by division? Now let's see. Now it says that 8 divided by 4 is a whole number. Whole number divided by whole number is a whole number. 5 divided by 7 is what? Not a whole number. 5 by 7 is not a whole number, right? 12 divided by 3 is a whole number, but 6 divided by 5 is not a whole number. No, no, and yes, right? So we say that it has to be all these, right? So we say that whole number is not closed under division, right? Yeah. Now I'll teach you one more thing. Just see that that division by 0 is not possible, right? Why the division by 0 is not possible? Because division is what? A repeated division is what? Better repeated subtraction. Let us suppose if I give you an example like 8 divided by 2, right? Use right. So what do you mean by this? Is a repeated subtraction. So this is equals to what, beta? 8 minus 2, which is equals to 6. Now 6 minus 2 is equals to what, beta? 4, right? Now 4 minus 2 is equals to what? 2, and 2 minus of 2 is equals to what, beta? 0, right? So you see that how many steps it took, right? Step 1, step 2, right? Step 3, and step 4. It took to get your answer 0 in the step 4. So your answer is what, beta? It is means what? The answer is what? 4. Now if I say that is 8 divided by 0. So 8 divided by 0, I'll just take a small number because it's going to be a very long. So I'll take 2 divided by 0, right? 2 divided by 0. So I'll write 2 minus 0. Yes, it is equals to 2. Now 2 minus again 0, which is equals to again 2. 2 minus 0 is equals to again 2. So will you get any time 0 or not? You're not going to get 0 at any time, right? So there is no step, there is no properly, it says that it's going to stop 0 and give you answer as what, beta? Give you answer as what, beta? 0, right? So in every move, we say that. So will this stop? This will never stop, right? This will never stop, right? Never stop. So we say, what is the important point we learned? So division of any number. So division of any number by 0 is not defined. Because we don't have any defined answer. So this is really very important point. Please keep this in your head. Write it down. Okay. Okay, now coming to the next property, what is a property that is a commutative property? What do you mean by commutative property? Just change of the position, change of your position, right? So whole numbers are said to be commutative under addition and again the multiplication. You have an example over here, change of position, just change of position. If I'm writing this is whole number 1 and this is whole number 2 and I'm applying the mathematical operation plus, minus, multiply and then divide, right? So your answer has to be what beta? Whole number and whole number 1. Change of position. A and B, agar if this side left hand side A be written, so here BA has to be written. So you apply mathematical operation plus, minus, into and divide, right? So this is the important thing right over here. So you just see that is commutative. If you add any order, like if you see that for addition, this is written already written, so I'm not going to write it again and again. So for addition, if you add in any order, beta, if I say add 2 plus 3, your answer is 5. If I add say 3 plus 5, 3 plus 2, so your answer is again 5. Now, if I'll say add 7 plus 8, it's 15. If I'll say 8 plus 7, it's again for 15. So you add in any order, doesn't matter, right? Similarly for the multiplication, and we have seen the multiplication right now. Over here, only we have seen this. This is what this is known as what beta. Again, I'll say this is known as what beta? Commutative property. Commutative property, right? Commutative property, right? Commutative property. Right? This is known as what beta? Commutative property. So what happened? You change the order, doesn't matter, right? So A into B is equals to B into A, which is equals to 2 into 6 and 6 into 8. Doesn't matter, right? But this is not applicable for subtraction as well as for the division also, right? So let's take an example for subtraction. Little bit, let's be fast. Okay, for subtraction, if you're going to see, if I'll write 2 minus of 3 and if I'll write 3 minus of 2 are the same. Right now you don't know the answer and here you know the answer, right? So they are not same. They are not equal, right? Similarly, if you take the division, if I'll write 8 divided by 2, right? And if I'll write 2 divided by 8, both are what beta? Whole number. Here the answer is 4. Right now we know, and this is what 2 divided by 8. If you know a little bit much about it, this will be what? 1 by 4. Are they equal? They are not equal, right? So it means what? It is not always, it's not, definitely it's not going to be, right? So we say that whole number, whole number is not close. I'm writing like not commutative, is not commutative under subtraction and division, right? Right? Under subtraction, because this answer is going to be -1, right? So they are not equal, right? Now, coming to the third property, that is an associative property. Associative property means what? The whole number, again said to be, you will be saying, ma'am, every time you say for a whole number. Yes, whole number are generally associative under the addition and only for sub multiplication. It's not associative with like a multiplication and division and subtraction and division. I'm just showing you the examples also, why not, right? So just take an example over here. Right now you have a block. This is a block of 4. This is 4 into 2 block, right? So you are adding this 4 into 2 block, 4 into 2 block, 4 into 2 block. This is equals to what? 24, right? Total, if you just sum it up, it will be 24, right? Either you multiply, right? So what happened now? Can I take the other block in this different way? Like this is a block of 3 into 2, right? And then I took, instead of taking like 3 blocks, I took the 4 blocks. Still I get the same answer or not, right? So what do you mean by the associative property? Associative property means what? If there are 3 numbers, how you're going to make an association with the other. Association means what? How you're going to be associated with the other person, right? So you just see over here, if I'll write that is A, if I'll write A, this is A, this is A, B, and C. There are 3 person over here. How you're going to make the association? So first, I want to make A and B. I'm associated with A and B, right? Now, A is a friend of B, right? So A is a friend of B. Now, together, they're a friend of 1. See? So we have to put a bracket. Now, what happened? Now, they have to be what? Now, they said, A says, okay, I want to be friend with B first, right? So he leave the A behind and he says that B plus C, right, are the same. Yes, they has to be same, right? So I'll give you an example like 2 plus 3, right? And this is equals to 4, right? Is it equals to what? 2 plus if I'll say, for example, that A is equals to 2, B is equals to 3, and C is equals to 4, right? So this is 3 plus 4. Are they same? So first you have to follow the BODMAS rule. So this is equals to what? 5 plus 4 is equals to 2 plus 7. So this is equals to 9 is equals to 9. So we say that yes, it is closed under addition, right? Now, if I talk about the multiplication, we have seen this is a visualization of it. Visualization may, if you take an example of A into B, right, into C. Now A is associated with B and he left C. Now what happened? Now he will leave A behind and make an association with the C, right? So B into C. So this can be equals to what, beta? 2 into 3 into 4, right? We have just learned now it doesn't matter in which order we multiply. So this is equals to what? Now you might be thinking, ma'am, this is all useless, but it is really important. You should know, because what happened, these little things will help you in solving the questions, and some tricky questions, they will help you to solve it, right? So this is equals to what? 2, 3 into 4, right? So this is equals to what? 6 into 4, and this is equals to 2 into 12, which is equals to what? 24 is equals to 24. That is why we say that it is closed under multiplication and addition. But this is not closed again in the under the division and subtraction, right? So I'll just give you again an example for subtraction, right? Subtraction and division, it will not be closed. So right now you don't know the solving properly. If you know the solving, then it's very fine. So if I write A minus B minus C is equals to what? A minus of B minus C. I'll take same numbers, right? A is equals to 2, B is equals to 3, and C is equals to 4, right? So let's take the numbers. So A is what, beta? 2 minus 3 minus of 4, which is equals to 2 minus of 3 minus of 4. Right now you don't, that is 2 minus 3 is what? You don't know. Minus 4, right? Which is equals to 2 minus of, now I'll give you an example. Actually, you don't know this thing, but I'll tell you what it is. If you understand once, then it's good to go. If not, please pay attention. You have to wait a little bit. You have to just keep a patience for this thing to understand when you'll be learning the integers addition, right? So if anyone knows it, I'll just solve it for you. So this is minus 1 minus 4, which is equals to 2 minus of minus 1, right? So this is equals to minus 5, and this is equals to what? 3. So they are not equal. If you understand, it's okay. If not, we'll do this in the integers. Please have a patience. Just now I'm explaining this part. Once you have done the addition of integers, you will understand how this thing happened, right? Now, if I take an example of what, beta? A divided by B, and this will be what? Divided by C, which is equals to what? Now A divided by B divided by C, right? Now just see, this is 2 divided by 3, and this is divided by what, beta? 4. This is equals to what? 2 divided by 3 divided by 4, right? So you will be writing this as 2 divided by 3 divided by what, beta? 4, right? So this is what? This is not a whole number, not whole number, right? Not whole number. So you just leave your answer like this, right? So this is what? 2 divided by what, beta? 3 by 4, right or not? So this is again what? Not a whole number, not whole number, right or not? So we say that whole number, we say that what is a whole? The whole number is not closed, is not closed, is not closed. If we say it's not associative, is not, is not, is not associative, associative under subtraction and division, right? Right. Now, coming to the properties of the whole number, that is known as what, beta? Distributive property. Now, distributive property is a very nice thing. So, first I'll be explaining you the questions on First, I'll be explaining you the questions on basically only addition and multiplication. I will take this distributive properties more lately in later on with your other chapters also, but not now, because we right now we have not done the multiplication of the negative numbers, right? So when we'll be doing the integers, everything will be very clear. So just take an example. What do you mean by the distributive property? What he did what? He has a block of 6, right? So blocks of 6, 6, 6. So 6 can be written as what, beta? 2 plus 4, he just broke it, and he has 3. So what he did, that is 3 into 4 plus 6. And what he did, this is equals to what, beta? 3 into 2? Yes or no? This is equals to what? 3 into 2. And this is equals to what? 3 into 4. Can you do this blocking or not? Yes or no? That is how he did, right? So what he did, actually what he did in mathematical form, distributive property means what? He wrote 3 into 2 plus 4, right? So can I write this as 3 means what? You multiply this into this will be what? 3 into 2. and then you multiply this into this, which is like plus sign, because in between there's a plus sign, so you write plus sign. That is 3 into 4. He did the distribution like this. He took the 3 into 4 parts and he did 3 into 2 parts, and then he summed it up. The vice versa also exists, right? So if I have written like 5 into 3 plus 5 into 4, what will be the answer? So can you see that 5 and 5 is common? So can I write this as 5 bracket into this will be what? 3 plus 4, right? Yes or no? And I could write like this also. If I would written like 5 into 8 minus of 5 into of 3. Can you see that 5 and 5 is common? So this is equals to what? 5 into, now 8, there is a minus sign, so minus 3, right? Now if I'll write one more question, if I'll write 8 into 5 minus of 3 into 5. Now you see that 5 and 5 is over here. Doesn't matter, it is on which side. So you can write this as what, beta? 8 minus of 3 into 5. Are they same? Yes, because 15, 5 into 3 is 15. 15 plus 20 is equals to what, beta? 35. And 7 into 3 plus 4 is what? 7. 7 into 5 is what? 35. So this is equals to what, beta? This is equals to what? 35 is equals to 35, right? Now you see that 5 into 8 is what? 40, minus 15 is equals to how much, beta? 25, right? So 8 minus 3 is what, beta? 25. 8 minus 3 is what? 5. 5 into 5 is what, beta? 25. Yes or no? So 25 is equals to 25, right? So similarly, you can do like this also. So what happened? This distributive property, how this is useful. So sometimes when the questions are given to solve, you can just break the number in a various form and get your answer. So if I give you the multiplication, say I say, if I say multiply, if I give you the question multiply, like 8 into 8 into 102. Yeah. So 8 into 102. So what you will do, you can just break this number into the nearest number. So can I break this as 8 into 100 plus 2? Yes or no? Now apply the distributive property. So can it will be what? 8 into 100 plus 8 into 2? Yes or no? So this is what, beta? 800 plus 16, which is equals to what? 816? Yes or no? This is the distributive property. This is the usage, right? So there will be a lots of usage of distributive properties. Okay, now let's coming to what do you mean by an additive identity? Okay, what do you mean by an additive identity? You just see over here. What is an additive identity? It says that additive identity gives the whole number when added to the other number, right? So 0 is the additive identity, means what? 0 plus a is a whole number. We did this question above. You just see that there are 5 kids, right? And if you add none of them, your answer will be what? Again, the 5 kids? Yes or no? So what number, like what a number may, a number in a number, what should be added to get the same answer, right or not? What should be added in a number to get the same answer? That is known as what, beta? Additive identity, right? So if I say that 5001 should be, what should be added to get, wait a minute, something happened again. If I say if I say if I say in 5101, what should be added? Like in 50,000, in like in yeah, in 50,101, what should be added to get the answer the same? 50,101. What should be added? It should be 0. Obviously, if you're playing, if like you, this is a very good example over here, right? So there are 5 kids who are playing and there it remains the 5 kids. So how many numbers of the kids added into it? So 0 kids are added. So basically we say that 0 is the identity, right? 0 is said to be what, beta? Additive identity. Now if I'll say like, this is why, that is why we wrote a plus 0 is equals to a, where a is any whole number, right? So 0 is the additive identity and it's written very clearly over here, right? So what number should be added, what whole number should be added in a number to give that number? We did in the, like in the first lecture only, in the first, like in true and false, what should be added? So that is a 0. If you add 0 into any number, you get the same number, right? If I'll add like let's take 153, what should be added? It will be what? Again 153. So this is equals to what? 0. Again, this is applicable for subtraction also. What number should be in a number? What should be subtracted to get the same number? That is a 0. But we exactly go for the additive identity, right? Now let's coming to what do you mean by multiplicative identity. Multiplicative identity means what, beta? Multiplicative identity means what? Give the same whole number when multiplied by the other number, right? So what in a number, what should be multiplied? Like if I say a number 2, in 2, what should be multiplied with the 2 so that you get the same number 2? That is what? 1. Yes, because any number multiplied by 1 gives you what? The same number. So 1 is the multiplicative identity, as a into 1 is equals to 0, and a is called as a bit of whole number, right? So just see an example, like 1 into 3 is 3, 1 into 6 is 6, 1 into 8 is 8, 1 into 17 is 17, 1 into 74 is 77, 74, 1 into 99 is what, beta? 99. So we say that 1 is the multiplicative. That's why you'll hear the word additive identity and the multiplicative identity. Additive means what you're doing, addition. Multiplicative means what you are multiplying, right? There is the difference, like addition and multiplication, right? So it means what? Additive identity means you're adding a number, and then multiplicative identity, you're multiplying a number. So if I give a number like 1910937, like this is the number, and what should be multiplied to get the same number, right? So it will be what? 90,101. It will be what? 1. So 1 is called as what, beta? This is called as multiplicative identity, right? Multiplicative of any identity number is what, beta? 1, right? So multiplicative identity, right? Multiplicative identity. And 0 is what, beta? Additive identity. So we have done this thing, right? Okay, what is the multiplication by 0? Multiplication by 0 is what, beta? 0 only, right or not? Yes or no? Yes or no? So just write this multiplication by 0, right? Okay. Okay. If I say multiply 5 into 0, right? So this means what? 5 into 0 means what? This is equals to what? 5 minus of 5 or not? Which is equals to 0? Yes or no? Can I write this or not? So I'll give you an example how this works. Now see, if I write 5 into 4, which is equals to what, beta? 20. Now 5 into 3, which is equals to what, beta? 15. Now just see. Now 5 into 2 is how much, beta? 10. 5 into 1 is equals to how much, beta? 5. Now 5 into 0 is how much? Just give a close observation over here that just see that you are subtracting 5. I'll write it over here. Subtracting minus 5, right? Subtracting minus 5. Subtracting minus 5. So what will be, you will be doing over here? Subtracting minus 5, which is equals to what? 5 into 0 is equals to 5 minus of 5, right or not? So this is 5 minus of 5, which is equals to 0, right? So we have this number, right? So we say that, thus, if A is any whole number, then A into 0 is equals to 0 into A. Can I say this is a commutative property also or not? Right? So if I say that 1001,091 is like multiplied by what? 0, what will be your answer? Your answer is 0. Right? So you just take an example. This is an example. Like if you write 5 into 4 is 20, 5 into 3 is 20, 15, then what you're doing? You're doing successive subtractions. So you see that when you come to the 0, you will get at what? Minus 5, right? So this is how we say this. Okay. Okay, so we have understood like multiplication, additive identity, multiplicative identity, properties, closure property, commutative properties. I think so. We have a commutative property, associative property, distributive properties we have done. So we'll be doing the questions. See here, I have taught you the concept. In the next lecture, we'll be more into the concepts, right? We'll be more doing the questions on it. So if you have any doubt regarding it, please ask it on the PDF or ask your respective teacher in the class. And if you have and hopefully you have understood this concept, and before the next lecture you see the video, please go through all these concepts, and then you go on the second lecture where you will be seeing the recordings of the questions on it. Okay, so thank you class, and that's all from my side. Welcome. Bye bye.